Thank you very much. Show of hands, and I love being in person so I can ask this again. How many of you guys grew up watching Star Trek reruns after school? Yeah, okay. My peeps. Space, the Final Frontier, right? And I think it's inspired a lot of what we're seeing emerge today.
How many people grew up watching the first run of Star Trek?
Okay, Mad Dog. I think it's you. But anyhow, yeah, no. I've been at the Linux Foundation now for about 6 years, and my focus in my career has been in embedded systems, from compilers to OSs and so forth. And embedded systems, we need to figure out how we can get things to be reliable, because it's a lot harder in certain circumstances to update and change things. They need to be maintainable. And in the last few years, I've been starting to focus more on to what do we need to do in order to be able to use embedded software and open source software in safety critical spaces, which ties in a lot of the themes of things that I've been caring about through my career. So I'm quite excited. And the highlight talk for me from this last year actually was in September from Tim Canahan. And he was at the Linux Foundation's open source event as one of the keynotes. And he was talking all about Linux on Mars. So I was just geeking out like you wouldn't believe. And one of the statements he made struck home to me, which is, you know, in many ways, it was a conventional Linux hobbyist project. And, you know, all the components are there are hobbyist projects. And then all of a sudden, this all gets put together by these folks, and it makes it up to Mars. So the Ingenuity drone, effectively, has Linux running on the copter itself as well as its base station. And we've got, it's a Qualcomm chip, and that is where the Linux system is running, and it's tying into Zigbee to do the communications. And so these are all things that are off the shelf and common parts. And most of the software, I think, for this is actually available online and free. The F Prime is the Splite software, as well as there is these various Linux builds that are used. And when he started talking about, okay, here's all the pieces that are inside, it was sort of like, oh, this is cool. They're using Linaro's build, which was Yocto. And the challenge with embedded is it isn't always obvious what software is running in them. And so one of the things is like, oh, I get these little cookie crumbs here and there. And it's like, oh, that's Yocto, yay. And then Linux, obviously. And then they were talking about, you know, how the BSP came about and then what was running on each core. And then they're using various utilities from the Linux kernel. You know, basically doing the bzips for taking the logs, doing the compression, and you know, and then monitoring the system. Are you, using all your cores effectively on this processor? Things that we'd all sort of do if we were working on systems here on Earth. But obviously, when it's running over there, it's going to be harder to do an update and do a fix. So I'll be posting the slides. The links are there if you want to watch the video itself and listen to him firsthand. I don't work for JPL and NASA, but I've just been really super geeky about this whole stuff. And then the other thing it was also on the Perseverance, the rover, and the cameras were being running Linux. So we had Linux running in multiple places here already. And this one was basically using an x86 and a 415, a more recent kernel. And so he was going into all of the details of this. But you know, it's also running Python, it's FFmpeg, it's curl. A lot of these utilities are there. And one of the things I thought was absolutely wonderful is they reached out with GitHub to give badges to everyone's open source project, to all the developers of the projects whose code was actually made it up onto Mars. I thought that was a beautiful touch. And I think we should be doing more of that as communities, is acknowledging the wins when these are milestones, because we all build upon each other in open source. And that's part of where the magic's coming from. But it's not just there. We know it's been, at least since 2013, it's been on the space station. We're seeing the basic robots. They've got some free-flying robots that are now there on the space station that are running to act as assists and carrying things around. And so we've got these free-flying ones. We've got some of the Windows stations that Mad Dog was talking about have been converted over to Linux. There's no point in sending it back down to Earth. It's still good hardware. Let's get software out that runs. And so we've seen that happening in the last 10 years. And then even more recently with the SpaceX work, they're using Linux. So they're even using the preempt RT patch, which I thought was kind of fun too. But they're seeing it on the spacecraft and on their rockets, we're running Linux, and in the satellites, in the Starlink system. So if you look at this, right, it's, there's 30,000 Linux nodes sitting there in our Starlight system circling the Earth. And so that's a lot of Linux out there in space. And I've got some links here if you want to read, if you enjoy geeking on this subject and the final frontier effectively. There's a lot of things that are emerging, and I think we'll see more in the years to come. And I guess the important part is Linux. Well, it started off as a hobby 30 years ago, and stick around after this. We'll be celebrating the 30th birthday of Linux. And it was, there was a book that was put out in 2001, just for fun, which gives a bit of a background. And inside Linus is a quote, "And sometimes revolutions just get stuck with it." And that's the challenge too with open source, is you put something out there and then people want you to support it and keep supporting it. And so the question is now, how do we start to get these types of things to scale? Because right now, Linux is one of the most important pieces of software platforms ever. It's dominated most of the markets it's gone to over the last 15 years. And even in embedded, it's at 69%, at least as of the numbers I could find in 2019. I haven't found any more recent numbers, but I think it's probably even higher. But the fact that we've got Linux sitting in all these places and driving so much of the world's infrastructure, it's kind of a larger, for something that started as a hobby and then just persisted for 30 years, it's a lot of questions as to why has it succeeded and what can we learn from it. Now, one of the things I like doing is doing some data mining on the kernel. I work with a researcher up at University of Victoria called Daniel German. And there's a project called Craigit. And basically it does an analysis of the Git commits onto the kernel down to the token level, which is, if you think of a line of code, it's all the variables and symbols. Each of those is a token. And that gives you a higher fidelity than just a line level to understand what's managed there. But right now, there's still tokens in the kernel back from the very first version. We've been able to parse it by resequencing the full Git sequence through it at the token level. We can find evidence of pieces in there that have been persisting since '91. So we build upon each other, we refine it, we enhance it, but we've been building on it for this whole period of time. And so I've got the data up to the 5.14 kernel. I've got some of the later kernels. We'll be working on them and finishing off the 91s, the 21 stuff. But these tokens replace themselves over time too, right? As you add new features, as you rewrite code, you'll see that, this was in 2020 for the 5.8 kernel. And there was, 2009-64. It's down a few. So some of those tokens have been replaced. But the fact that you can literally go back and see tokens and evidence of how people are participating to the kernel, to me, is very fascinating. And it sort of shows we all have to build upon each other in the bridges we make. Now, another project that's got opening hobbyist roots is Yocto. And in 2003, they created a BitKeeper repository for it. So we have the full history there too. And then Richard Purdy worked on Pokey, which became the start of what eventually became Yocto. And in 2010, it was announced as a project. And they aligned with the OpenEmbedded and started to work on releases. And that Yocto is a distro for embedded. It's a way of basically forming a distro. And so, thanks to Phil Ballister for helping me understand what the timeline was. But it also is like, okay, these two projects, Yocto is there for Mars, Linux is there for Mars. There's a lot of projects out there. There's, hundreds of millions if you look on GitHub and GitLab stats, right? So the challenge we see, and this is something we've been seeing in the OLF, is which projects really matter, which ones are going to persist. And more, it's the challenge is what's going to be sustainable? How can we sustain things over time? And to a large extent, it's sort of who's building up an ecosystem? How is an ecosystem building up on these things? And I'd say more than sustainability, we need it to be dependable. If we're going to be having some of these softwares go into these critical infrastructures, we need to start figuring out how we can make it dependable so that people can rely on it. Because fixing bugs in some of these embedded systems is a lot harder, and then potentially there's consequences to safety critical lives and infrastructure, power grids, things like that. So at the LF, this is a slide that Jim Zemlin uses, and it really does tend to resonate with what seems to be working, is you have to have a developer community using the technology, and then have effectively commercial people making products around it to help support the infrastructure so that people can do development. And people can get jobs. And so we have something that's sustainable. That, at the heart, is a lot of what we're seeing with some of these projects, and seems to be working with both Linux and Yocto. So the Yocto project was one of the Linux foundations. After Linux itself, Yocto was one of the first projects we started at the LF. It's available to members, but anyone can participate. You don't have to be a member to participate in the project technically. But the infrastructure is there from the members who are getting value from Yocto to help fund, testing hardware. Help fund Richard Purdy to make sure he stays neutral, right? Michael Halstead runs the system. Steve is working on the LTS. And then Bootland for documentation and integration work. These are tasks that not every developer wants to do. So the challenge now is, there are things that developers enjoy doing, and there are things that developers don't want to do. And for a project to be successful, both need to be there. So remembering the hobbyist roots, we're seeing basically a good growth in developers emerging in the Yocto core, and the commits are at a pretty good level coming in from this perspective. And these are not just members, these are all the community that's happening, and the OpenEmbedded participants. So the technical is there, we're working there, and these slides were just recently created by Nicholas Deschen for the Yocto Dev Days, which happened 2 days ago. So it's pretty fresh. Now on the Linux kernel side, like Yocto, the contributors keep growing year on year. So for like last year, I'll get the stats probably in another week or two's time for 2021, but for 2020, there's well over 4,100 developers participating in the kernel, putting those tokens in last year. So just think of that. There's over 4,000 people participating in coding on the same project. That's sustainability. And it was, in some ways, probably, like I say, I'm curious to see what the final numbers are for this year, whether it's higher or not. But it was one of these things that I thought was interesting. And obviously the commits, all those features and the churn and changeover and refinement and bug fixes and so forth, up till the latest date I've got, 2020 has been, another peak year. How much of that's COVID? How much of that's new trend line? We'll find out. And as I said, it's going to take real work to get these projects to be sustainable. There's things like releases. Not every developer wants to work on a release. There's things like making sure that there's trademarks associated with it. There's guidelines. There's infrastructure, obviously, and then the best practices are followed. And then security. Who wants to fix the bugs? What's reliability looking like? These are elements that we're going to need for open source to be sustainable and dependable in the future. So one of Jim's sendings is, 80 to 90% of the software these days in modern systems is written by external parties. You don't have direct control over it. And we need to start creating a culture for secure coding backed up with incentive, resources, and training so that we can actually scale and keep the scaling going. And so now contrast that to the hobbyist contribution to open source. People are doing things, and this is where the innovation's coming from, We need the hobbyists to stay engaged in open source. And some of it's spare time at home, like because you enjoy coding, you like learning the new things, you enjoy working with the community. These are sort of the main reasons I've heard. And then there's more and more discretionary time at work. a lot of enlightened companies will give people like a day a week to do what they want to do. And they still provide a salary. And so they can explore ideas, they can do new features. This is also a sort of what I would call a sort of supported hobbyist, because they've got a salary associated with it. But they're doing things that are advancing the innovation. However, they're doing it for fun. They're not doing it for, they're not doing it for the view of, okay, I want to go fix, some people like fixing bugs, don't get me wrong, but it's sort of like, there's certain things, certain tasks they don't want to do. I don't want to write documentation, or I don't want to do that. Very instead. So at the start of the year, the Linux Foundation and Harvard's Linux group got together and did a survey of maintainers to try to understand what the motivations were. And we were looking at this from the viewpoint of, okay, secure coding. But these motivations are valid here for dependability as well. And the top one was people are doing this because they want to fix a feature, something they need. Then they enjoy learning. That was number 2 motivation for paid and unpaid people for contributing to open source. And then, it allows me to fill a need for creative challenge and enjoyable work. That's why people want to contribute to open source. That's why I want to do the Hobbyist. And that's where the innovation's coming. That was I'm paid to develop FOSS was actually the least most popular. Number 10 was the least important, which was a bit of an insight. I had not realized that before we saw these results coming in. And then, they weren't really caring about it for their careers, again, paid and unpaid. Or for that matter, recognition of the peers. Like I say, we put the survey out and we heard back from these maintainers. This is what they valued, which sort of resonates with the just have fun. I want to have fun. I want to do something that's interesting to me. And hey, if it helps someone else, great. The other thing we saw from that survey is that the employers, their policies have improved. The free to contribute, that extra day, the supported thing, we're seeing that go up. And we're seeing, it used to have more of an unclear policy 10 years ago. Now it's much more clear. So, we're seeing some interesting trends. Some of them still require permissions, but fewer are not permitted at all. Mostly everyone's accepting that they can contribute out to open source in a lot of the companies now. So we're knowing that open source is critically important today. Most of the code bases based on Synopsys' study contain open source. On the percentage of the code base is 70%. And if you're starting to look at app space, the components per app, 5 years ago were about 84, now it's over 500. This is all a very modular system, and it's all building upon what others have done. These are all building blocks. So they're all building blocks. How do we deal with this one? This cartoon came out from XKCD last year. I love it. It just summarizes so many problems. So we have some person in Nebraska that's been thanklessly maintaining something that everyone else depends on and no one knows about. We also have the foundational pieces too, quite frankly, don't get me wrong. These are the Linux kernels, these are the Yoctos, these are the tool chains, the build infrastructure. Things are important. But understanding, we've got a lot of really sophisticated infrastructure, and having the transparency to understand that is one of the problem areas this is where it touches into licensing for me, because the transparency and software transparency and understanding what software you're running is key to fixing things, okay? If you don't know what's running on your software to a couple levels of, through the dependency trees, if there's a bug there, you may not know. If there's a vulnerability there, you may not know. If there's a hazard coming in from that from a safety perspective, again, you may not know. So getting the dependability aspects, I'm just going to use Wikipedia definition. I figured enough people have looked at it, everyone agrees on it. But availability, reliability, maintainability for durability and safety and security. When someone's doing something for fun, are they thinking of all these aspects? Likely not. However, when we start to use the work, we've got to start to think about these things when it's showing up in places like space and in things that are safety critical. And so I'd say that the next challenge for us all is, getting dependability with open source working well together. And this is personified very clearly in the embedded market segments, in the industrial segments. getting the robots working that interact with people in shelves in big warehouses, okay? They could hurt someone if they run into them. Medical devices, yeah. I don't want anyone sort of snapping the data off of my device, seeing the data. I want security there. I want secure communications. I want to know that no one can hack into it and give me too big a dose of medicine, or some sensor monitoring information is skewed or something like that. Automotive, we know that Tesla's got cars running Linux today. There's other places we know that Linux is showing up in these automobiles. If there's a glitch somewhere, that could actually impact someone's life. So the world is changing. And software is emerging everywhere. But the challenge is a lot of the methodologies that have been used in the past for analyzing the safety aren't really scaling to what's happening in open source. So the other things, I guess, are obviously energy infrastructure. And as we were listening this morning, we're seeing these different systems and building the trust and having that trust in the systems as to what can be executed in places that, code from hobbyists can impact people's lives, flat out. So the other thing that's sort of interesting to look at, and this came from that earlier study, is where do people want to spend their time? What is actually important to them? Well, you can sort of see that this is reality. They're spending most of their time. They do like to do a lot less maintenance on their code. What they really want to do is spend more time developing new code and improving the features. That's more fun. And then fixing security. Hey, way down there, okay? Security isn't what people are caring about. But it is, certainly where we need to be focusing to make sure that we can trust the software and it becomes dependable in these spaces. So, in my mind, this is the next big challenge for us in the open source ecosystem. Is how do we scale our projects for developability? When someone makes a decision to open source something that they've worked on, hey, it's useful to someone else. You've got a personal project you've done on GitHub, it's self-maintained, it's fun. You might attract one or two other people. Okay, that's fine. If they want to use it, good, but this is a way of sharing, but you don't have to worry. But then someone starts bringing more dependencies on it. I didn't sign up for that. I haven't signed up to support all those, but they're finding it useful. So how are we going to scale that? How are we going to scale that interaction? And, is the developer consciously thinking what they want their role to be? How long can they support it? A lot of people sort of burn out because all these people are sort of coming after them. And so the projects that we look at that have succeeded, what things have actually worked for, people defining their roles and then figuring out how long they're staying engaged. And then the other challenge I'm going to say, based on what I'm seeing from these motivations, are, how can you architect things so others can participate? Be that rearranging your code, partitioning it differently, carving out certain tasks, re-architecting the modularity so that you minimize interference, basic software engineering types of principles. But if something's becoming really popular, how can you make sure you engineer it so there's other people who can do the things you don't want to do? Figure out what you want to do, figure out what you don't want to do, and then make it possible for others to participate, especially if they have a need for it. So how we can start to scale our projects and open source projects for dependability is what I consider quite a fascinating space. So I'm going to give a few examples here. We've got the Linux kernel, which we've talked about, real-time Linux, Lisa, Yocto, civil infrastructure, automotive-grade Linux, Zen, Zephyr, and then the Open Security Foundation. Talk a little bit about them, but not all of them. I'm just going to focus on a few. So what's worked? Well, in Linux, I think one of the biggest insights was establishing that maintainer hierarchy. I think that was probably the key for starting to scale this up. Now, and there's been a laser-like focus on quality. You can't get a new feature in unless you can prove it's improving the quality compared to what's there. So this has gone for a lot of back and forth when people want to put their new ideas into the kernel, and there's a real justification and a technical meritocracy that emerges. And this has caused the code base to be evolved, and various models were tried in the 2.6 time frame, and then when we moved over to 3.0, that we hit on the cadence that we're working on today, and the release cycles, and the methodologies, and then there's that focus that, hey, you're not going to break the user API. And that's let, I think, the project scale. The The other thing that's emerged is the technical decisions aren't coming from one company. It's coming from a wide consensus that's independent of who's funding the project. That neutrality has been key, I think. And then, quite frankly, it's the people who are benefiting from Linux who are funding the infrastructure. They're funding the servers we're using. They're funding Linus and Greg and Shua and Konstantin and others who are working the infrastructure for Linux. So that's what the membership of the Linux Foundation is doing, is helping to support this to happen. Now, other steps that have emerged are the notion of having a long-term support. This made it possible to make products and to keep the change rate down, but still have the key fixes you want. And that's become really attractive for the infrastructure side, from the civil infrastructure. There's a security focus. There's people who care about security and make sure that the fixes get backported and that regression testing is happening. Not every developer wants to work on that, but there's groups of people who do. And so carving spaces so that they can work on it effectively is key. And so getting those carved spaces and people who have a vested interest in making these things happen is one of the things that I consider a really healthy dynamic from the Linux kernel. So like real-time Linux patch, the preempt RT patch set, was being carried outside the kernel. No one really wanted to finish it off. A group of companies banded together and have funded, for the last 4 or 5 years now, the slow and steady upstreaming of the preempt RT patches, such that the main methodology in another year's time, well, hopefully in the next 6 months actually, everything that will be there, so that a lot of the analysis we use for safety on the kernel, from what's upstream and all the rigor there, you're not carrying an extra set of patches for when you want to use real time, which is going to be key for embedded, because I got involved with needing embedded back in, I guess, 2007? For when I used to work at a company, we needed to have the embedded preempt patches. So I've been sort of aware of them, and we need them, but so forth. And then recently, there's a bunch of people that are banding together to improve the kernel CI infrastructure. The ELISA project is basically trying to figure out, okay, how do we collaborate on the processes for dependability and making things safe? Such that if you're using something in a safety critical application, you can do the right level of analysis and you have processes, because quite frankly, the standards really can't, they envision a different model of development and they look at things at a system level rather than at those component levels. And so we have some impedance mismatch. The thing is, the kernel has a lot of things it's doing right, and so how do we figure out how to do the right level of analysis to know that a system is truly safe? And then the civil infrastructure. Well, when you've got your street lights working for 30 years, you don't want to go up and update the software by putting people up there and so forth to change things. And trains, the software, the automobile cycles, some of these things, actually it's not the automobiles, that's a different set of rules, but the whole infrastructure, having ways that we can standardize that and keep things supported. They're working with the Debian project as well as the Linux kernel. And so these are some of the things that, Linux has provided a place for people to collaborate on problems together. That's helped to scale it up for all the contributors. And then it's also been very good about being public about documenting the best practices they're doing. You can go and look at the best practices badge for security. For Linux, it's one of the few gold badges. There's I think less than 10 of them, and Linux kernel is one of them. And one of the other things I do is I'm a volunteer for the Linux Plumbers Committee. And so I help put on the Plumbers event every year for the developers. And this year, Mad Dog was kind enough to keynote for us. And at the end of his keynote, he was looking back over 30 years, and we asked the developers, we asked him a little survey. Okay, what do you think is going to be happening? And the developers there, pretty much, and this was all virtual, once it filled in, we had 203 fill in the survey, and I think Linux will still be as popular 10 years from now. Yes. That was a pretty overwhelming yes. So the community is happy working with the infrastructure they've got today, is my basic read on that. And that's partially because there's been separation, there's been logical extension so people can focus on what they care about the most. Sure, there's friction here and there, okay, but to see that, that proportion still thought that Linux kernel would be sustained, I think was an interesting indicator for me. The next sort of challenge we're looking at is, okay, how are we going to get Linux working in these safety critical spaces? and get the analysis done. So there's a group of companies that are banding together and working with some of the, the TÜV suits and the experts in the certification like UL, Underwriters Laboratory, so forth, to talk about this and figure out, collaborate, what's the process that's going to make sense to you, to everyone. And so the OLF project is basically looking at, okay, how are we going to define that common set of elements so that we can build an industry consensus up about what makes sense, and then people can apply it in a sane way. And no one's going to come up with this idea on their own. They're going to be coming up through discussion, through talking, and trying ideas, and then evolving. So innovation is needed in this area, no question. Another case study is Yocto. Again, early collaborative OLF project. It's evolved its governance since it started. The governance was actually reworked in 2019 to improve the neutrality and clarify the interactions with OpenEmbedded's TSC, the Yocto TSC, and the governing board, where the money is. Like the kernel, the project directly funds the architecture and infrastructure to keep it neutral. And then members with that commercial interest are funding it to have the infrastructure there that they can all share. They've introduced having a long-term support. That was something that the members wanted to have. It's being used heavily for the automotive-grade Linux. All that infrastructure for AGL is based off of Yocto, so that people will take it and customize it and work from there. One of the things that they're doing that I'm really excited about is they've been very strong adopters of the reproducible builds and adopting security best practices for that, so that you have the full reproducibility happening, the ability to have that, which is going to be key for traceability and software understanding exactly what software you've got. And they're also very much at the forefront of improving the transparency and automatically generating a software bill of materials. So you can do your builds now for Yocto and generate an SBOM to have your full traceability of your dependencies. So that type of level of transparency and traceability helps with the visibility and be able to track down and understand if you are impacted or not by a vulnerability or some other flaw in the software. And as you can see now, Yocto's project is very diverse. We're getting multiple companies participating in the core and non-core. It's not dominated by any one company. This is a good story. It's got robustness in the ecosystem. It's not just one big elephant that is dominating a project. The fact that we have the diversity there and that the project is continuing to grow and attract more members means that we have more discretion on some of the infrastructure we can fund. And so there's no shortage of ideas. Like the Yocto Project right now is working on their 5-year plan and working at, and information's coming in from the members, from the TSC community, and they're trying to figure out, okay, as more members come in, what should they be funding, what should they be prioritizing? A slightly different one that's a bit more recent on the scene is Zephyr. Now, this project was just launched in 2016, and it was launched because, quite frankly, Linux doesn't get smaller than 2 meg these days. And there's a heck of a lot of sensors and actuators out there where the fractions of a cent are necessary. They don't want to have long power budget. And you need to be able to be in a very resource-constrained space. So Zephyr actually takes a lot of things and lessons from the Linux kernel. And the code base is very familiar to an embedded Linux person. It's using kconfig, it's using device tree, it's using these standard mechanisms. And so it was launched with the neutral government with 3 members at the start. And we evolved until it's over 20 members now with the project. But like the Linux kernel, the technical decisions are made by a TSC. They're made by the maintainers, and there's a TSC for this project rather than just a hierarchy, a Linus here. But the technical decisions are independent of the funding. The developers manage the code. And the project's funds from the members is supporting our build infrastructure. It's supporting the people doing the project management, the people arranging meetings, things that help keep a project vibrant and interacting and innovating on a technical side, doing things that the developers don't want to do. So that lesson we've learned from Linux, we applied it here, and it seems to be working out fairly well. The code base is continuing to evolve. We had micro and now kernels initially, and it was refactored into one kernel. We've basically had a lot of new communication stacks that have been added over time. An LTS was forecast. We planned right from the start to do LTSs because we saw that working in the kernel in this project. And we just finished putting out our second LTS. And that is the basis that we're going to be doing for safety and for our safety certifications this year with this project. Right from the very start, there was a security committee. It became it manages vulnerabilities. It's handed bulk vulnerability reports. It's one of the few open source projects that's deliberately recognized as a CNA by MITRE for handling its own vulnerabilities. And it's got a PCERT team for resolving them. So it's trying to find the best practices and apply it here in the deep embedded space. And then this project is one of the few, and it's working with some few others, that has a safety committee. And they've actually, the funding from the project has hired a functional safety manager because none of the developers want to do that. And that's working to articulate the artifacts and work with the standards and then work with the certification authority to make the project certify. Now the code, there's agreement in the developer community here to align towards MISRA coding standards. So and we're working on putting tooling in place to make that happen so that anytime you check in, you're sort of configured. Because a lot of what's in MISRA is weaknesses. It's trying to avoid weaknesses in the code base. So it's a good thing to do. It's higher quality. But having automatic checking, getting it on things, is what's going to help us get our dependability levels up and hopefully get 61508 certification next year. One of the other things that Zephyr is doing is it's got, in the build infrastructure there, again, you can automatically generate a software bill of materials on every build. In fact, it generates 4. One for the Zephyr code, one for the SDK, one for the app, and then one for all the build artifacts, the libraries to the executable, and linking back to the appropriate sources. So you have full traceability for an executable to exactly which sources made it in. And this was really useful in, going forward. And what drove it home that we needed this is last year Amnesia 33 came out, and that was FNet. It was a vulnerability with FNet. And we had FNet in our LTS. We knew we had some of that code there. It wasn't in our latest mainline or our tip, but it was in the LTS. And so we had to do the analysis to support the LTS. And none of the files that had the vulnerabilities in were actually in there. But if you just looked at the version numbers, it would say, oh, you've got FNet, you must be affected. Well, no, you have to look at the source files to know if you're affected or not. So we had no way of signaling this other than putting out a blog post for the project. We had to say, no, we're not affected, we're good. Nothing to see here. Now there's other ones we found that we were affected and they've been remediated. But being able to have that level of responsiveness and the transparency is, I think, where we're going to need to go as a wider open source industry. And then, like the Linux kernel, there has been a best practices badge, and that's now under the OpenSSF. And what it is we basically publicly document all the processes that Zephyr follows and make it visible to people. And anytime we can find a new best practice, we're trying to apply it here. So OpenSSF is looking at figuring out how do we identify these projects, how do we make sure they're secure, how do we build up the ground level of security and knowledge in the industry. And we can apply it in some of these projects, and we can apply it to other projects too. There's a lot of other projects there. What projects are most critical? This is the one that's this group is looking at that and trying to understand that beyond these. And to look at whether or not Zephyr has been effective, as you can see, we start off with 4 boards in the project. There's now over 350. I think actually it's closer to 400, but I couldn't confirm it before this talk. So we've got a pretty good long tail of contributors. I think actually when I refresh this mix, it'll be a little more thing. But when we started off, it was pretty much 2 or 3 companies, right? And we've been slowly and surely pushing back the diversity and increasing the robustness for the code base. I missed a typo there. There's over 1,000 there. My bad. I'll fix it in the slides before I post it. But there's over 1,000 contributors now into Zephyr. And so 1,000 contributors. We were actually, in this project, we're seeing 2 commits an hour right now. The Linux kernel, for perspective, is about 10 commits per hour. And so for a deep embedded project, as an OS, that's kind of has something we're pretty proud of. So a few final thoughts to leave you with. So when the project's popularity and dependencies increase, starting to think about how do we architect it so that others can participate effectively, and consider re-architecting the code so that we can get the quality and the maintainability we're going to need. If there's a lot of people that are depending on it, it's kind of worth spending the time to do that. Not everyone wants to do the same thing. Not everyone thinks the same thing is fun. Recruiting other resources to do things you don't want to do as a developer is something we need to start looking at as, on a wider. So you need to build up these communities. You need to build up these ecosystems. I think if we can do that, that seems to be working. If your project is getting really important, make sure the governance is known. Ideally move it to somewhere neutral, but at least let people know the terms they're contributing under. I think these are all things that help establish good best practices. And then, these are modular blocks that are used in systems. Start to think about system engineering. Start to think about how the interfaces work. I think if we can get that clarified, all these things can start to get us to that dependability scale. So I think the world needs open source innovation, no question. Challenge is going to be how do we figure out how we can do it for sustainability and dependability. And with that, thank you. And does anyone have any questions?
What specific use case does Zephyr used for?
So Zephyr is being used right now in things like hearing aids. So Oticon's product line of hearing aids has Zephyr in it. We're seeing Zephyr being used in being welded onto the side of garbage trucks because it has to have a long battery life. And so every time a dump truck goes up, it triggers a signal. We're seeing it being used in tracking. We're seeing it being used in power management. It's a very, very lightweight OS, and it doesn't consume a lot of resources. We know that Zephyr is being used today in things like wind turbines. And so it's embedded, though. It's hard to find. We find it through communication paths things. Bluetooth, there's a lot of very interesting Bluetooth applications emerging. And that's some of the Bluetooth certs. That's how we find out some of the products. But you'll see it in quite a range of ecosystems right now. And I suspect you'll see a lot more rolling out next year. Go for it.
I had a hard time reading all the companies. The type is a little bit light, but what I did notice was there were no aerospace companies, Boeing or anybody else in that list.
I know. I'd
So
love to have some.
Well, we can talk about that. The automotive piece, though, I'm curious,
Sure.
how much of that is devoted on the safety side to autonomy?
So mostly right now, there's a lot of people that are interested in the autonomy space, and the training data stuff isn't really showing up into some of this area yet. But there's a lot of people working in that. On the Zephyr project, it's more happening in terms of some of the sensors and the actual LiDAR. So we've got a member in Zephyr Bomber Sensors, and they're basically working on trying to make sure that their sensors can be working with this. Again, it's keeping the constraints down.
Yeah, no, I definitely want to follow up with you about
Okay,
that.
sure. Anyone else have any more questions? Well, thank you very much then. Appreciate your attention.